This is section 3B. So the first one, area, expanding circle, twice as fast as its radius. So the idea is, here's your basic area function. And this is a related rates. It's talking about, hopefully you're seeing the rate portion of it. So I took the derivative, and this is what you end up with. Oh, sorry, this is your derivative, this is what you end up with. This is the relationship that's stated in the problem. So the area is expanding, increasing twice as fast as the radius in linear units. So this is relationship from the problem. This is the area formula, and this is its derivative. What I decided to do was I took out the dA dt, so basically the rate the area was expanding, and replaced it with the other side of the relationship and kind of solve from there. And that's why 1 over pi is equal to r. This one probably isn't truly linearization. This is kind of more of a rates problem. This is a hard one. So you have a point on this curve, which ends up being just an upside down parabola. What point on this curve is nearest to the point 0, negative 1/2? So 0, negative 1/2 would be, I'll make it red right here, and it wants to know which is closest to it. Is it right here? Is it right here? Is it right here? So the idea is you have one given point, and you have one new point that you're trying to find, and you're trying to minimize the distance. So this actually is a min-max problem. So I use the distance formula. 0 take away x, negative 1/2 take away y. The y, though, I replaced with this, which is just the equation. Kind of plugged and chugged from there, set it equal to 0, and it ended up being the point 0, 0. Mean value theorem, nothing too crazy. For kind of just look through the work there. Linearization, you could skip this one. And we could skip this one as well. Related rates, so you have a radius of a sphere that's increasing at a uniform rate of 0.3 inches per second. At the instant when the surface area becomes 100 pi square inches, what is the rate of increase per second of the volume? So I know that the radius is has a rate of this. I know the surface area is equal to 100 pi, and I'm trying to find what that is, how that is impacting the volume at that moment. So there's my surface area and my volume formulas. Went ahead and took the derivative of surface area and the derivative of the volume. The thing is that you kind of needed to get through this because you didn't really have enough information once you took the derivative to go anywhere. They told you surface area was 100 pi. So if you go ahead and you take that information and set that equal to the surface area formula, you can figure out what your radius is. And once you know what your radius is, you can kind of do the math kind of hanging out there. Because you know your dr dt is 3/10 or 0.3. Radius squared is 25, and then you have your 4 pi. I was just kind of canceling some fractions because this was non-calculator active, and you end up with 30 pi. Another lovely related rates problem. So you have your volume. You know that your radius and your height both increase at a constant rate of 1/2 centimeters per second. So I recorded that information there. There's my volume formula. At what rate in cubic centimeters per second is the volume increasing? And the height is 9 and the radius is 6. So I want to know the derivative of volume essentially. So this is unfortunately product rule. Just kind of watch your math as you go through, but it's pretty much once you can get it set up, it isn't too terrible of a problem. 157. The average value on a closed interval. So there it is. We've done a lot of these. This ends up being a U substitution, unfortunately, but there isn't a lot for me to say other than you can kind of look at the algebra and go from there. We did a similar problem to this in our notes. You have the size of a rectangle. They increase that z, the rate that z is changing is 1. X is changing is equal to 3 times the change in y. The instant that x is equal to 4 and y is equal to 3, how is x changing is your job in this problem. So there's all the information kind of written down. What I did decide to do is I saw for dy, just so I would have both of those, whether or not I needed it, and put in my 3, 4, and I found out that at that instant, z would be 5. Pythagorean theorem. Pythagorean theorem is the relationship I used. Take the derivative, kind of do your math from there. This is a max-min problem, I think. Yep. So you need to know volume and surface area. You're trying to minimize surface area. What is the height that minimizes it? R is a constant, so there's no implicit differentiation required with R. Kind of keep that in mind. And you just kind of see how I work through it. It's a lot of math, but it isn't anything that I think is too terrible. Mean value theorem again. I guess just memorize the mean value theorem, unfortunately. Be careful when you do your substitution that you have that going on. So that's x divided by 2, so you have to take 1/2 of what your x is. It's probably the trickiest part of this. And then set that equal to 0, and you got to know your trig stuff as well. So the relationship that you get, this is your derivative, needs to be equal to 0. So cosine of x over 2 equals 0. That's going to happen at pi. So kind of just keep that in mind as we go through. And the idea is, I'm trying to get my pen wherever that is. Okay. The idea is you're putting, this is cosine of pi over 2 is what really goes in there. So I know cosine of pi is -1, but we're doing pi divided by 2. Cosine of pi over 2 is 0. Oh, this is the ladder problem. I think I actually assigned this to you guys at some other point in the year. So this is my dimensions for my ladder. And these are my rates for my ladder. Use the Pythagorean relationship and kind of just plug and chug from there. We did this one as well, I think. Radius of a circle is increasing at a non-zero rate. Certain instant equal to the rate of the circumference. So this is what that is telling you. Derivative of each side. Kind of do your replacements, plug and chug. So I replace dc dt with all of that loveliness. Your pi's cancel out. And then you kind of have those guys cancel out, which gives you r equals 1. This one, we don't talk a lot in pre-cal about even and odd and how that impacts sine and cosine. And this typically doesn't show up a lot, but this was asking for the average value. I'm okay if you got to my answer. Okay, so if you got to like some form of this, the idea is because sine is odd, sine of -3 is equal to the opposite of sine of 3. So that's a substitution they made to get to the +3. But like I said, if you got to some form of this, that's great. Don't worry about going any further. Railroad track, we did this semester review somewhere around there. So this is my distances. Remember, this is after 4 seconds. And then these are your rates. You're trying to find the rate at which your observer is going to be standing here. He's not moving, and you're trying to see how fast the train is moving from him. This is my little train. How fast he's going away from him. Pythagorean theorem. Put your values in, plug and chug. This is the intermediate value theorem. So the idea is a function will take on any value. So this is my A. This is my B. It's going to take on not a good B. Every value between here. I'm not drawing it right, sorry. So there's my A and there's my B. So the Y values are going to be every single place in between here and here. If I wanted my function to go down and grab that point, then my B needs to kind of be lower as well. So at some point, if I want to grab that, then I got to have a function that kind of swoops up or swoops below it. It's kind of the idea. So that's why it has to be 0. This was a repeat. Radius of a circle is decreasing at a constant rate. In terms of C, what is the rate of change of the area? So radius is decreasing at negative 0.1. Here's your circumference. The thing is instead of working with r, we suddenly want to work with c over 2 pi. And you want to know what is the rate of change of the area of the circle, so dA dt. Area, take your derivative, 2 pi r dr dt, you know what dr dt is, replace it. And we don't want to work with r, we want to work with that, so I replaced it. It looks, actually, it works out kind of nicely. Negative 0.1c.